Alright, so this is going to be Algebra 1, Section 1, Semester 1, uh, Lecture 1, Section 1, 2, 1, 3, 1, 4. The first section deals with order of operations and evaluating expressions. You guys should know that when you raise something to a certain power, say 2 to the third, that the 2 is called the base, and the 3 is called the power, or the exponent. The base is going to be the number that's being multiplied over and over and over again, and then the power or the exponent is the number that tells you how many times you are multiplying the base. So I will be multiplying the base 2 times itself 3 times. So they give you down here for problem B, they give you 2/3 to the third power. This third power applies to both the 2 and applies also to the 3. So it's going to be 2 to the third power over 3 to the third power, which is 2 times 2 times 2 times 2, or 3 times 3 times 3, and that gives me an answer of 8 over 27. There is a common error that people make when they do these types of problems. The difference between this problem, 2/3 with the 2 being raised to 3, and the 2/3 in this problem, the 2/3 with the 2/3 in the parentheses, is that if it's in parentheses, that means that it applies to the whole fraction. If there is no parentheses, then this 3 square only applies to the 2. So it's going to be 2 times 2 times 2 over 3, or 8 over 3. If there is a parentheses, then the power applies to both the numerator and the denominator. If there's no parentheses, then the power only applies to the numerator. PEMDAS or GEMDAS. Please excuse my dear Aunt Sally. When we do these, sometimes people call it GEMDAS, G for groupings. The P is for parentheses. The E is for exponent. M is for multiplication. D is for division. A is for adding. S is for subtracting. G can also mean groupings instead of parentheses. So these guys are interchangeable. And parentheses only refers to these two guys. Groupings refers not only to parentheses, but brackets as well, and other types of brackets. So it's a little bit more inclusive. So some people call it GEMDAS too. Thing to note. Of the PEMDAS. Actually, let's do this. multiplication and division have the same power. Multiplication and division have the same power. In addition to that, addition and subtraction has the same power. So when we see both addition and subtraction and multiplication and division, the way that we tell each one apart to do is from left to right. Whatever you see first on the left, if they have the same power, is the one that you do first. So if we had 10 take away 5 plus 4, this minus sign is happening first from left to right. So I'm going to do the 10 minus 5 first, which is 5 plus 4, and then the answer is 9. Same thing with adding and that is multiplying and dividing. If we had 10 times 5 divided by 2, multiplication comes first from 10 to 5, so that's 50 divided by 2, and then 50 divided by 2 is 25. So multiplication, division, same power. You go from left to right, that determines which ones you do first. Adding, subtracting, same power. Again, you go from left to right, and that determines which one of those you do first. So when we do one of these, for example, if we look at A, we have 5 times 7 minus 4 squared divided by 2. 5 times 7 is, we have multiplication, we have subtraction, we have exponent, and we have division. So PEMDAS says to do the exponent first, so its next step is going to be 5 times 7. 4 times 4 is 16 divided by 2. Now we have multiplication, subtraction, division. Remember that multiplication and division have the same power, but multiplication occurs first from left to right. So then 5 times 7 will be 35 minus 16 divided by 2. We have subtraction and then division, so then we're going to divide. So it'll be 35 minus 16 divided by 2 is 8. And then 35 minus 8 is 27. So we did exponent first, so we did power first. Then we did multiplication. Then we did division. Then we did subtraction. That was A. B, we have 12 minus 25 divided by 5. So we have subtraction and division. We do division first. So 12 minus 25 divided by 5 is 5. So we got here, we did division. And then 12 minus 5 is 7. And that was subtraction. Okay. C. We have 4 plus 3 to the 4th over 7 minus 2. So when you have fractions like this, it's a little bit different. We still get to do the power first. So the next step will be 4 plus 3 times 3 times 3 times 3. What is 3 to the 4th? 4 plus 81 over 7 minus 2. So that's, we did power. All right, so here's sort of the difference. We can sort of do the numerator or the denominator separately. It's almost like they're parentheses, and it doesn't really matter which one you do. In a lot of ways, a lot of people actually, in their brain, I've even seen people physically do it, put parentheses in the numerator denominator over in the fraction sign in between, which means that it doesn't matter which one of these you do first. You're going to divide it last, as it were. So 4 plus 81 is 85. So I added in the numerator. And then 85 over, over 5, I subtracted in the denominator. And then 85 divided by 5 is 17. And we divided. And it's all because these things are sort of considered in parentheses first. And it's kind of annoying because it's a little confusing because it doesn't follow like, why am I dividing last? It's sort of an unwritten rule that is there in it. I wish they would actually show that in problems because it would make a lot more sense to do so. Got it. Number 3 is the same as we just did. It's just substituting numbers. So that's your section 1, 2 rather. So section 1, 3, square roots, number lines. If we have a number and it's square rooted, this guy is called the radical symbol. This guy is called the radicand. And then the radicand and the radical symbol put together is called a radical. So a radical is the radical symbol plus the radicand. In the case of what a radical is and what a square root is, a square root is the number such that when you multiply it by itself, will give you whatever is inside the radicand symbol, whatever number this is. So I got to multiply a number twice, and that number has to get me that number that's inside the radical symbol. In that case, since I multiply 7 times 7 to get 49, then I know that 7 is the square root of 49, because I know that if I multiply 7 by itself, I will get that same number. That is a square root. They give us some examples of it. We went through all of these in class, so I'll just go over the last 3. So if we look at B, we have the square root of 25. I know that the two numbers that I have to multiply together to get 25 is 5. So since I'm multiplying 5 twice, I know that the square root of 25 is 5. For C, I'm square rooting the entire fraction. It's almost like if I was to rewrite it, square root of 1 over the square root of 36. I know that 1 times 1 equals 1. I know that 6 times 6 equals 36. So I know that the square root of 1 over 36 is 1 6. 1 6 times 1 6 gives me 136. So that is C. And then D, I have 81 over 121 root the whole thing. That's the square root of 81 over the square root of 121. I know that 9 times 9 equals 81, and I know that 11 times 11 equals 121. Therefore, the square root of 81 over 121 is 9/11ths. We're not going to do that. So we talked about last time we met about the number system and natural, whole, irrational, rational numbers. Remember that natural numbers like 1, 2, 3, ... They're positive numbers. No fractions and decimals. And it does not include 0. That does not include 0. So we start at 1. And they're all positive. No fractions and decimals. Does not include 0. That is natural numbers. Whole numbers . 0, 1, 2, ... Same thing as natural numbers, positive, no fractions or decimals. And then the one difference is that it does include 0. It does include 0. So those are whole numbers. Then we have integers. And integers, -2, -1, oh, ... 0, 1, 2, ... Remember the ... means that it goes on forever in that direction. We have positive and we have negative numbers. That's the big change. No fractions, no decimals. And does include 0. Notice that one always builds on the other, right? No 0, positive, no 0, positive, 0, negative, and positive, and now 0. It's always building. And those are integers. Then we have rational numbers. And rationals like -1/3, 0, square root of 2, 6.88 bar. Actually, I wrote that wrong. 6.8 bar, ... So, positive and negative, includes 0. In addition to that, we do have fractions. We also have terminating and repeating decimals. Terminating and repeating decimals. So a terminating decimal is something like 1/2. 1/2 is equal to 0.5. It stops after the 5. A repeating decimal is like 1/3, which is 0.3333, and it goes on forever, which is the same thing as saying 0.3 bar. So, rational numbers, positive and negative numbers, it includes 0. Fractions and decimals are good, but the decimals have to be terminating, they stop, or they have to be repeating, they go on forever, and it's the same number that goes on forever. Those are rational numbers. And then, oh wait, did I put square root of 2? Wait, square root of 2 is not a rational number. Scratch that. Square root of 2, not rational. Sorry, my mistake. Not rational. Sorry. Alright, so irrational. Is numbers like square root of 2. Say square root of negative. No. Let's say negative pi 0 ... Square root of 2 ... So irrational numbers, any number that's not a perfect square is an irrational number. So square root of 4 gives me 2 as the answer, which means that it is a perfect square because it's the whole number as your answer. However, something like the square root of 2 gives me a decimal that goes on forever, and it does not repeat. It does not repeat. So square root of 2, 1.4, 1421356 not a perfect square. Not a perfect square. So irrational numbers, in addition to all the stuff that a rational number is, in addition to that, it's also numbers that goes on, that does not, actually no, none of that. Irrational numbers is in a category all of its own. Those are numbers that don't repeat and goes on forever. Don't repeat and goes on forever. Those are irrational numbers. So anything that's a non-perfect square will always be an irrational number. Always. Okay. Inequality, 2 less than 5. We know that the guy, sometimes they give it teeth and it's a hungry alligator. Always eats the bigger number. So 2 is greater than 5. I can also say 2 is greater than or less than or equal to 5, right? If they're potential to be equal, I can say 5 is less than or equal to 5. This equal sign says that it can be one or the other. We can do it the other way. 5 is greater than 2. We can also say that 5 is greater than or equal to 2. They all mean the same thing. Like I said before in the lecture previous, I'm not going to ask you guys to do any number line stuff on the test. All right, properties of numbers. We have the commutative property of addition, which says that if I have two numbers, let's say 4 plus 6 and I switch the order. So 4 is first, now 6 is first. 6 is second, 4 is now second. They both still give me the same number. I also have the commutative property of multiplication, which says that if I switch the order and multiply, that doesn't change the answer as well. Commutative property works only with addition and multiplication, does not work with subtraction or division. Then we have the associative property of addition, which says that if I have 2 plus 4 plus 6 in parentheses, 2 plus 4 plus 6. The order of the numbers don't change. 2 is first, 2 is first, 4 is second, 4 is second, 6 is third, 6 is third. What changes is which two numbers I decide to add first. In this case, in the left, I add the 2 and the 4 first, which gives me 6, and then 6 and 6 gives me 12. On the other side, I add the 4 and the 6 first, which gives me 10, and then 10 plus 2 gives me 12. So it doesn't matter which two numbers I add first, they will still give me the same answer. And then we have the associative property of multiplication, which says if I multiply numbers 1 times 2 times 5, 1 times 2 times 5, put the parentheses here again. The order is the same. 1 is first, 2 is second, 2 is second, 5 is third, 5 is third. However, in this case, the parentheses is over the first two numbers. 1 times 2 is 2, 2 times 5 is 10. Here, the parentheses is in the last two. 2 times 5 is 10, and 10 times 1 is 10. Doesn't change the answer depending on which order you add, or which two numbers you add first. All right. Identities. So we have addition identity and additive identity and multiplicative identity. So identity of addition says that if I have a number 2 and I multiply it times 1, that's not adding at all. If I have a number 2 and add it with 0, that gives me 2. Any number plus 0 equals itself. That is the additive identity. And then the multiplicative identity says that if I have a number, multiply it times 1, it equals itself. Any number times 1 equals itself. Additive identity, any number plus 0 equals itself. Multiplicative identity, any number times 2 equals itself. And then we have the multiplicative property of 0. So multiplicative property of 0 which says this: any number times 0 equals 0. Always. Except for, any number times 0 equals 0. That's it. And then that's multiplicative property of 0. Then we have the multiplicative property of -1. So multiplicative property of -1, which says that if I multiply a number times -1, that's going to be its opposite, its inverse. This also works with negative numbers. If I was going to do -2 multiply it times -1, I'm going to get 2. 2 and -2 are opposites, they're inverses. So it works. 2 here and negative 2 here, they are opposites. It works. So any number times negative 1 will always produce its opposite or its inverse. Okay. I'm going to do these last two, and then that is it. So we here for got it number 1a, it says 4x times 1 equals 4x. That is the multiplicative property of 0. Nope, that's the multiplicative identity. I'm sorry. I'm rushing. Multiplicative identity. Meaning that any number times 1 equals itself. 4x times 1 equals 4x. 4x equals 4x. Multiplicative property. Multiplicative identity. B, we have x plus root y plus z is equal to x plus z plus root y. So we have a x in the first, y square root of y in the second, z in the third. Here we have x in the first. Instead of y being square root of y being second, z is second, and the square root of y is third. Notice that the parentheses is in the last two numbers being added, and here likewise the parentheses in the last two numbers being added. So it is not the associative property of addition. This is the commutative property of addition, and it's the commutative property of addition because the order switch. The y and the z switched, so we switched the order. Therefore, it's the commutative property of addition. All right. I'll do a couple more. So for number 1 here in the check, do you know how? Lesson check. We have x plus 12 equals 12 plus x. X is in the first position here, 12 is in the second. Here now, 12 is in the first position, x is in the second, so this is the commutative property of addition. The order changes, but the answer is still the same. 2. We have 5 times 12 times x equals 5 times 12 times x. Notice that the order is not changed. 5 is first, 5 is first, 12 is second, 12 is second, x is third, x is third. The parentheses, though, changed. The last two here is multiplied, and then here the first two here is multiplied. So doing the problem, this is the associative property of multiplication because the order stays the same, but the two numbers that I multiply first changes. Looking at got it, do you know number 4? They want you to simplify 24. Remember, to simplify something doesn't mean to get an answer per se. It just has to be a usually with a variable involved. So here we have 24 CD. This C is being divided by this C. So 5 divided by 5 is 1. 2 divided by 2 is 2. 1. Then C divided by C is also 1. So these guys cancel out. So then I'm just left with 24D. And that's the answer. Okay. So that's section 1-4.